Ah. So we are using OpenGL. We're learning.
Yeah, sharp like an edge of a samurai sword, the metal blade cut through flesh and bone. Though my mind's at peace, the word out of order, missing then the heat. Light gets colder. Oh yes, I have to find my path.
Bye, Liam.
No less walk on earth, water and fire. The elements compose a matter. Opens my modus operandi is amalgam. Steel packed tight in microchip.
Right now we're working with shaders. And the syntax of GLSL, which is the syntax that you have to write for shaders now.
Some days, some nights, some live, some die in the way of the samurai. Some fight, some bleed, sun up, sun down, the sons of a battle cry. Some days, some nights, some live, some die in the name of the samurai. Some fight, some bleed, sun up, the sun down, the sons of a battle cry.
Here, let's do a vertex.
Battle cry.
So here's the vertex shader that I just wrote. You're gonna have to specify a version, right? So version 3.3, and then we're gonna specify that we're using the core version. Now after that, we're gonna have to specify I think it's this is where I'm kind of fuzzy and new. I think location equals 0 is we're going to start at the origin, so like 0 pixel, and we're going to specify in so that's like okay, I'm calling this from memory. In vec, so okay, this is vec3 intuitively is a vector in R3, right? So maybe I could vec3 is a vector R3. So what that means is that there's going to be an XYZ, and then we're calling this vector A. Now we're going to open up a void main, and we're going to use this predefined GL position variable. So this is predefined. GL position is something that we are going to store all of our final position data in. I think I made a note about that actually. Yeah, so we're going to set the output of vertex shaders and store position data in this predefined variable. But this predefined variable takes in a vector in R4, so we're going to cast our 3D vector to a 4D vector, and we're just going to use the position data from a pause. So and finally we're going to set the W position to just 1, and I believe that's a float, and that's it. This is the vertex shader right here, specifically this, and that's what I put in here. Yep, I was right. Or maybe I'm not right. I don't know. But anyways, Now, right now, I outlined the steps that we're gonna take right now. So we need a shader object, the reference ID, and let's just get to it. Ah. That was embarrassing. I don't even need this. Okay, let's keep going. Something good to know from here is, okay, so if we're writing our fragment shader, we can declare output values out, okay? Obviously, for a fragment shader, it's going to be, we're going to be outputting color, right? And colors are stored in, tuples of, like, I guess a length of 4, because there's red, green, blue, and then alpha, which is opacity. We just learned. So let's write a fragment shader. Oh wait, we just start with this. Specify. Now let's make a variable out, and it's going to be a vec4 fragment shader. Fragment data. process for compiling fragment shader is the same thing, except we're going to use a different flag here for GL fragment shader. So let's do that.
Feel like your tooth sensitivity isn't severe enough to deal with? What if I told you Sensodyne has a fast and simple remedy? New Sensodyne Clinical Repair starts to repair sensitive areas of teeth after 60 seconds. I'm so excited to introduce this new product to patients. New Sensodyne Clinical Repair is absolutely amazing.
This all looks good. This all looks good, man. Now we have to link shader objects into a shader program that we could use for rendering. Good ass song, man. Good album. This is so good. Oh. So this is good enough to include. Alright. So this is gonna be. This is gonna just be a shader program. And I'm guessing it's gonna be like create program. Yeah, okay. This should be alright. location of the vertex attribute 0. Want to pass data to pass in 0. Stored in a 32-bit 4x4. Each position is composed of units. Yeah. Why don't I get this? Am I stupid? The first parameter specifies which vertex attribute we want to consider. Is this, like, remember that we specified the location of the position vertex. And the vertex shader with layout. Happen. Oh, okay. I get it. So what we're saying is that each vertex, right? So yeah, each vertex has different attributes associated to it. In my case, the way that I'm describing my triangles is three vertices, or like, yeah, 3 vertices. Each vertex is going to have its own respective attributes. But in my case, the only attributes that I want to really assign these vertices is its X, Y, and Z position data. But as this person on Reddit said, if we have a vertex buffer with position, color, and texture coordinate data, right? So in my case, I only have position, but if you have these 3 pieces of data, then data for a single vertex in memory could look like this. So this is X, Y, and Z. This is your unsigned float, which is your color, or unsigned int, which is your color. And then what is the last 2? The last 2 is the UV component of the texture coordinate. Now, in my case, I only have these first 3 floats, right? And the vertex handling this data with this function right here, this 0 to 3, I'm guessing is 0 to 3 for like these first 3 like 4-byte sections. Is that what that means? Because this explanation is kind of weird. The first parameter specifies which vertex attribute we want to configure. Remember that we specified the location of the position vertex attribute in the vertex shader this sets the location of the vertex attribute to 0. Oh, I get it. So in this layout location equals 0, I'm gonna regurgitate what they said, but we specified where we want. Okay, so if we want to reference I don't know what else word to use, reference the position data in this function right here, the GL vertex attribute pointer. In the GL vertex attribute pointer, we can access the specified location data at 0 because that's what we set. Okay. So that makes sense. And what comes to 3? The next argument specifies the size of the vertex attribute. The vertex attribute is a vec3, so it is composed of 3 values. Okay. Yeah. This second argument is a little bit vague to me. Like, I get it. Let's see if more enlightening here. Specifies the number of components per generic vertex attribute. Must be 1, 2, 3, 4. Okay. The number of components per generic vertex attribute. I got it. Okay. This makes sense. So, okay, I'm guessing. This is okay. I'm not looking. I swear to God, I'm not looking like here. See my webcam? I'm not looking here. But this is my guess. This unsigned int is going to be position 2 with how many attributes? 4 because it's a vec4. Oh, duh. Okay, it starts at 0. It doesn't start at 1, but this makes sense with 4. This makes sense. Okay, I like this Reddit page. I'm gonna actually save this. Can I like save this in my notes? So we makes sense. Okay, so now we can move on. The third argument specifies the type of data. Yeah, we stored in each. This makes sense. I mean, the next argument specifies if we want the data to be normalized. If we're inputting integer data types, and we set this to GL true, integer data is normalized to 0 or -1. And 1 when converted to float. Yeah, this is not really relevant. The fifth argument is known as the stride. This is known as the stride and tells us the space between consecutive vertex attributes. Since the next set of position data is located exactly 3 times the size of a float away, where the position data begins. This is the offset of where the position data begins in the buffer. The position data is at the start of the data. This makes sense, man. This makes fucking sense. So let me rewrite this really quick. So we have a GL vertex attribute pointer. All right, so we specified 0 for the position data. Each piece of position data is going to be a vector in R3, so that's going to be 3. Our type is going to be a GL float because each piece of data is composed of just floating types. Next is going to be our type. Ooh, what was type again? Our type was GL false because we did not concern ourselves with like that integer normalization and stuff. Now our stride, because let's go here. So only consider like these 3 right here. This is 3. Okay, 1 vertex is just composed of this 3 floats. So this is 3 floats wide. All right, and we're gonna have 3 of those. So our next vertex in memory is going to be 3 times the size of a float, which is just 4 bytes. And now our const void pointer, we casted to 0, or we casted 0 to a void pointer because I guess our buffer started at 0. That was a little bit unclear, but it's okay. And now what's this? It's like enable something, yeah. Yeah, enable and we set that to 0. Wow, we are learning a lot today. We are learning a lot today. different objects?
また夜が明ければお別れ夢は遠き幻にあなたを追いかけていた光の中で抱かれるたび暖かい風を頼り春を告げ踊り出サンシャイン夏を目じ野原から草川秋の月のぼったままるさを祝い冬を過ぎまた月に数えまだまぶたの奥にあるいつかの夏と過ぎた青空暖かかった手をつなぐ花摘み歌ういつや思い出ではなく葉月から三月雲と絡む月いつか帰らぬことに目覚めた時一人気づきあなた探すたびに今呼び覚ます記憶の中でいつ歩き出すあなたのもとへまた夜が明ければお別れ夢は遠き幻に
Hey,
あなたを追いかけていた光の中で抱かれるたび暖かい
I just saw the chat.
風を頼り春を告げ踊り出サンシャイン夏を目じ野原から草川秋の月のぼったままるさを祝い冬を過ぎまた月に数え君によれらない抜き方よりに君で見た花の香り片目に結びゆく道あらばまた帰り目流れる涙止めそか熱
Yeah, I turned down the music. That's okay.
追い風叫ぶ静寂
Wow, I actually got like 9 viewers.
進むの黄金の花が運ぶの優しさにあなたに
I'll make sure to monitor that better. If anybody actually watches these, I will make sure to monitor this. At rate 9, what's chat rate 9? Alright, anyways. That's good to know. The vertex array object. Okay. This has the advantage that when configuring vertex attribute pointers, you only have to make those calls once. So and whenever we want to draw the object, we could just bind the corresponding vertex array object. Okay. Okay, so we are using core, so we have to use a we have to bind a vertex array object. Enable vertex.
In Hartford, Chase is proud to root for the home team because they're our team too. We cheer from the bleachers and on the sidelines.
Okay.
We cheer for gymnasts and quarterbacks.
This makes sense.
And with more than 25 local Chase branches and 5,000 nationwide, we're right beside you, Hartford. Neighborhood bankers, digital tools, national strength. Chase, make more of what's yours.
JP Morgan Chase Bank, N.A. member FDIC.
All we have to do is bind the VAO using bind vertex array. We should bind. From that point on, we should bind the corresponding VBOs and attribute pointers, and then unbind the VAO for later use. So we're gonna bind vertex array. With the vertex data defined, I'd like to send it as an input to the first process of the graphics pipeline. This is done by creating memory on the GPU, where we store the vertex data, configure how OpenGL should interpret the memory, specify how to send the data to the graphics card. maybe I don't get this step fully, but the step makes it feel like my past ones were quite redundant. Could be here. Look at all these. Makes it feel quite redundant. Or vertex attributes pointers.
There's enough needless nonsense in the world already. Your phone plan shouldn't add to it. Verizon's new Simplicity plan cuts down on the nonsense in your life. Now there's just one plan, one price. $30 a line per month, even for a single line. And everyone gets our best 5G network. It's a phone plan designed to do exactly what a phone plan is supposed to do. Isn't that a lot simpler? Switch today at Verizon.com or at your nearest store. For new customers, $30 per line includes auto pay and switch discount. Additional taxes, fees, and terms apply. Unlimited data is restricted to on-device smartphone usage. Domestic data roaming at 2G speeds. Failed to compile fragment shader. What would this look like right here? Most people don't know that you can get a domain from Squarespace. Not just a website. But you're not most people, because now you know you can get a domain from Squarespace. Something like velvetchords.com for your music studio. Or kidchords.com for your middle school band camp. Whatever your dream, Squarespace is how you make it happen, all under one roof. Get yours before it's gone with offer code MAKEITREAL for 10% off your domain or website. Terms and conditions apply.
Did I ever bind the vertex array? Okay. Yeah. It worked. Yeah, I forgot to bind the vertex array at the beginning. Cool. Nice, man.
I know the bliss, I know the check, bliss, you checking the beyond. I know the bliss, I know the check, bliss, you checking the bad, bliss, you checking the bad. I know the bliss, I know the check, bliss, you checking the beyond. I know the bliss, I know the check, you check, bad. I know the bliss, I know the check, bliss, you checking the beyond. I know the bliss, I know the check, bliss, you checking the bad, bliss, you checking the bad. I know the bliss, I know the check, bliss, you checking the beyond. I know the bliss, I know the check it, check it, check it, check it, check it. I got the blues, I got the blues.
Mix up your cat's mealtime with the Meow Mix playlist. Meow Mix has epic sound.
I'm just making notes on the structure of what I just did. It's just a lot to remember. Not very intuitive either, especially because I don't have like a rigorous background in graphics programming. So, I don't really know how to monitor my stream, so I do have. It says I have 2 viewers, so for anybody who's actually viewing right now, I just finished rendering like a hello triangle, and we got this. But yeah, I didn't really run into many issues. The only thing was this vertex array object was a little bit confusing on like why I actually needed it, but everything here was fine. Like these vertex buffer object, like it flowed pretty naturally. So right now I'm just making notes on this section right here about shader program. Yeah. Perfect. No. Now we can check to see the success of that. And yeah, now we just get our vertex attribute pointer. It's like enable vertex array or attribute array. Within our render loop, we can, so we are going to specify, So I think that's everything pretty much. So yeah, it would go, we have to have a vertices array. We need to create some vertex array object. Then afterwards, create a vertex buffer object where then we have to set its like identifier. We have to bind our vertex buffer object so the one that we created to the GL array buffer. Then we must copy our vertices array data into the buffer itself. So whenever we like reference using a GL array buffer, we're actually using the one that we created. Now we have to create our vertex and fragment shaders. The process is very similar for both, just except the GL SL source code is going to be a little different for each. They serve different purposes. Like the vertex shader is going to serve its purpose to specify, I guess, where the vertices are going to be outputted to the GPU, and then our fragment shader is going to specify to the GPU the color of the pixels, right? Create a shader program that links the vertex and shit. So we have to link those. So we have to okay, and then to tell the okay, so right here, linking vertex attributes. The vertex shader allows us to specify any input we want from vertex attributes. I like how they describe that. We have to manually specify what part of our input data goes to which vertex attribute in the vertex shader. This here, and I just that this will work. Okay, now what if I just got rid of this entirely and just placed it in the render loop? It still works. Yeah, I knew that was redundant. Like, I knew that was redundant. We didn't have to call, because we already placed this in the render loop. We already know to use the shader program. this is still kind of fuzzy to me. I don't know why we have to do this twice. That's cool. So I guess next time we're going to learn about element buffer objects. And maybe we'll tackle an exercise. You get really good grasp on concepts. It is advised to work through them before continuing to the next subject to make sure you get a good grasp of what's going on. How to draw two triangles next to each other using GeoDraw array by adding more vertices to your data. That creates the same two different triangles. And then we'll work through GLL, SL later. Do this later on. Alright. Cool. I'd consider that a successful day. I think maybe while I'm still on this, I will make more notes on a general program structure here, because I know that okay, this is just gonna take me like 10 seconds. I want to see if anybody's still watching that. Oops. My stream has been blocked. How about now?